Test 1, 2, 3. Test. Morning, everybody. Okay. This week's discussion is based on trigonometric differentiation. Yep. You must have covered it in the previous lectures. Okay, these questions are in Moodle Week 4 tutorial worksheet. So we'll go through some of the questions. On related rates, question 2, we'll have a look at question 2, question 6, and some on trigonometric differentiation. Now, for those of you who do labs, I believe chemistry, bio, and physics, you use the oscilloscope to take readings, and the oscilloscope on the screen, you've got wave-like designs. They use the concept of trigonometric differentiation. So we'll have a look at some questions on related rates. We'll begin with question 2. A spherical balloon is being deflated and the volume decreases at the rate of 49 centimeter cube per minute. How fast is the radius changing when the diameter of the balloon is 14 centimeters? What are we asked to find? How fast is the radius changing? What is that as a mathematical expression? Now we know that the basic principle of differentiation is based on the basic concept of rate of change. Differentiation is used to find gradients. Instead of y2 minus y1 over x2 minus x1, we use dy over dx. So in this case, you're asked to find the rate of change of radius. How fast is the radius changing? Now, what information are we supplied with? Here's one information. Volume decreases at the rate of. I need for you to write that as a mathematical expression. So let me just write this down. Hold on. Rate of change of volume. $49. All right, this is what the information supplied by the question. Rate of change of volume is 49 centimeter cube per minute. You're asked to find the rate of change of radius. So what's the mathematical expression representing rate of change of volume? It is dV over minute, that's over dt. And the unit also tells us centimeter cubed, it's volume, So dV over dt is given. What are we asked to find? Rate of change of radius. So we are asked to find d radius. That's the unknown. That's what we are asked to find. Now let's have a look at any additional information supplied by the question. Let's go back to the question. What we're told is the diameter of the balloon is 14 centimeters. Okay. And because the balloon is spherical, the volume V equals, what is it? 4/3. Okay. We need to construct a related rate equation for dV over dt that uses dr over dt. And that related rate equation is based on is extracted from the chain rule. So what is our related rate equation on dV over dt? All right. dV over dt is equal to something on dr over dt. There's something missing here. What should I have that's missing there? It is dV over dr, because if I cancel dr and dr, I'm left with dV over dt. Okay. dV over dt is given. Well, how do I find this expression? dV over dr. I'm given the volume equation. I can use this to find so, differentiate this volume equation with respect to radius. What expression do you get? dV over dr equals? I'll differentiate r cubed. I'll get 3r squared. I'll differentiate the r cubed. I'll get 3r squared. And that 3 will cancel with this 3 in the denominator. So I'll get 4 pi r squared. Okay. So now that I know dV over dr times dr over dt, which is the unknown. So for me to find dr over dt, I'll move all of these to the left. Definitely we'll have to divide. So do we know the value of r? Yes, no? It can be extracted from the diameter. Diameter is 14 centimeters, so what's the radius? Yep. So I'll substitute 7 there. So 49 what does that give us? 7 squared, 49. So 49 over 49. I'll cancel that off. What am I left with? dr over dt equals 1 over 4 pi. Yep. If you want to insert the unit, what unit shall we use here? Because we were using centimeter cubed. So radius, centimeter per minute. The unit is not really important here. So the challenge here is in two levels. One is converting the word sentence problem into mathematical expression. That's one level of difficulty that you have to encounter. Converting word sentence problem into mathematical expression. And the second level is trying to solve. So here, what we did, I think this is central. The rate of change equation. dv over dt equals dv over dr times dr over dt. Let's have a look at another question on related rates from the worksheet. Question number Question number 6. No, question number 6 is similar to question number 2. I want us to try out question 5. Question 5, yes. The surface area of a cube with side x is increasing at a rate of 12 centimeters squared per second. Find the rate at which the volume is increasing. Okay, when the side is 2 centimeters. What information are we supplied with? Rate of change of area. Yeah? What is that as a mathematical expression? Rate of change of area? dA over dt. 12. Okay. Can you construct your related rates equation? So it's got to be dA over dt equals something times something. What is the expression on the right-hand side? Because at the end of this calculation, what is it that we're asked to find? Rate of change of volume. What's the mathematical expression for rate of change of volume? dV over dt. Okay. So we need to plan out how to solve this. How many of you like the board games, chess and what board games do you have? So if you're good with those, then you should be a good mathematician. Because see, what we are doing here is before you write down your first step, you will have worked out the next steps. And that's what you do for those board games. You are anticipating the move of your opponent. And you're planning out what your next moves are. So that's exactly what we need to do. We need to work out how do we get to rate of change of volume. So let's write those down. What's that? Right. What's the mathematical expression for rate of change of area? dA over dt, what is it equal to? 12. And we are asked to find the rate of change of volume. When the side, let's give the side the variable x. Okay. What shape are we referring to? It's a cube. Okay? So, surface area of a cube is 6x squared. Volume of cube is, okay, right. This is what we're supplied with. This is your target. And we know that dV over dt, what's the related rate equation that we're going to use? Is dV over, instead of dr as in the previous example, we will use dV over dx because the equations are given in terms of x, the side, times okay? Now we can easily find the dV over dx from here. What's the expression for dV over dx? Differentiating x cubed, we get 3x squared, the set. So I know this, but I have a problem. I do not know the value of dx over dt. That I do not know. Now I'm thinking, now that I have an expression for dV over dx, I do not know dx over dt, but I know that this is given, dA over dt. I can find the value of dx over dt from the related rate dA over dt. So let me pause this here and let me go to dA over dt. What equation do we construct here? dA over dt equals dA over dx times. I know dA over dt. What is it equal to? 12. Okay. Somebody work out the expression for dA over dx. What is it equal to? dA over dx, we will differentiate A. What is it equal to? 12x. So that means I give you 1 minute. Work out the value of dx over dt. Go. Dx over dt. Oh, the attendance sheet is being passed around. Please make sure you fill in for you only. Thank you very much. Yeah, what's the expression for dA over dt? 1, is it? 1 over x, agree? And we know the x value. What's the x value? The length of one side is 2 centimeters. So dx over dt is 0.5, half. Okay, good. X is 2. Now that I've got the expression, the value for dx over dt, then I will now fulfill to work out the rate of change of volume. Yeah, go on, finish that off. So dV over dt, dV over dx, times dx over dt we now know is half. Yep. What is that equal to? X is 2. What is it equal to? 6, eh? Yeah. Again, if you want to put in the unit, I think it's centimeter cubed per second, eh? Please note the concept being used. Concept is related rates. You need to be able to construct the equation. Now, as you've seen from these two examples, that the concept is the same, we can change the equation design. So, expect you to be able to identify what concept to use. Okay, so we'll move on. Trigonometric differentiation. I assume that you've already gone through that. There's always a danger of assumption. They say that assumption is the mother of all problems. Okay, I'm assuming that you've gone through differentiating trig functions. What's the derivative of sine x? Cos x? What's the derivative of cos x? Negative sine x. What's the derivative of tan x? Sec squared x. Check? Yep. Differentiate sec x. You get sec x tan x. Differentiate cosec x. Negative cosec x, cot x, check, check. And cot x, differentiate cot x. Negative cosec squared x. So, don't expect us to ask you in the test on the final exam to differentiate sin x. No, no, no. We'll have to attach some other differentiation techniques to those trigonometric differentiation. Okay? All right. So, let's go through the let's see if we can go through all of them. Differentiate the following functions. Y equals cos 4x, what is it? Cubed. What technique of differentiation will we use here? Because see, you know the power rule. What else? Product rule, quotient rule, what else? Chain rule. When do we use the chain rule? Differentiating composite function. Agree? What else? Implicit differentiation. and the other technique. So my question to you is, what technique will you use for A? Y equals 4x cubed. Cos 4x cubed. Okay. This to me looks like a composite function. Why I say that because I can identify an inner function and an outer. So what would be the inner function here? For me, this would be the inner function. And the outer function is cos x. So that means, what technique shall I use here? Chain rule? So that means, let's go straight. I hope you've already formalized your short methods. So, as we had discussed last week, we'll firstly differentiate the outer. So we'll differentiate cos x. What's the derivative of cos x? Negative sine. What do I have here? The inner function remains the same? And then we'll multiply by the derivative of the inner function. So, what do we multiply with here? 12 x squared, because now we are differentiating the inner. And again, we expect you to rearrange it properly. There. Move on to the next one. Negative 3 sec to x cubed, okay? Yep. What differentiation technique shall we use? I believe this also looks like a composite function. It has an outer and an inner. So again, I'll use the chain rule. So, I'll give you 1 minute, try that out. Work out the derivative. Go. So I'm suggesting we use the chain rule. Differentiate the outer. What's the derivative of sec x? Sec x, 10x, eh? Check, check. Yep. Oh, this is good. Please, please try this out. I need everybody to try this out. So the negative 3 remains, eh? Differentiating sec, you get sec x 10x. So in this case, negative 3 remains. Yep. Sec of something times tangent of something. Now, what should I have here? What should I have here? We said when you differentiate the outer, the inner remains, eh? So what should I have here? 2x cubed. The inner remains. And then we will differentiate the inner. What's the derivative of the inner now? 6x squared times. And again, I expect you to simplify that. I'll multiply the 3 with the 6x squared, that gives negative 3, that gives us negative 18x squared. Good. $20 minutes left. Let's move on. Negative 2. Hold on. Cot plus 1. Negative y equals negative 2, cot x cubed plus 1. Yep. Again, what technique shall we use? Believe chain rule again, eh? Because there's an outer and there's an inner. What's the outer here? Negative 2 cot. And the inner is x cubed plus 1. So we'll firstly differentiate negative 2 cot. What's the derivative of cot x? Negative cosec squared, yes. So, I'm trying to shorten steps for the sake of the test in the final exam. Eh? dy over dx, negative 2 remains untouched. And the derivative of cot is negative cosec squared. What should go here? The inner, eh? X cubed plus 1. Is that it? No, I still need to differentiate the inner. And what's the derivative of the inner? 3x squared. Please simplify this. So, what does that simplify down to? Negative times negative is positive, and then that should give me 6x squared plus 1. All right. Gx equals all right. Gx equals 4 sine cubed 5x plus 2. So, it looks like an inner function, an outer. So for me, chain rule works here. Now I think when we were discussing chain rule last week, I said that there's a possibility that you will have to apply chain rule more than once. This is one example where you will have to apply chain rule more than once. Because the way I see it, there will be 2 inner functions. Or before we differentiate this, I want us to write sine cubed 5x plus 2 properly so that it's differentiable. Now, you should know this. I expect you to know this. Sine squared x. This is the formal way of writing sine x squared. Yeah? So if this is what this means, so I will rewrite sine cubed. I cannot just differentiate it straight away. So I'll use this technique. I'll rewrite sine cubed. What will it be? 4 sine cubed. Now the way it is written, like I said, so what's our outer function here? Outer function is 4x cubed. We did something similar to this last week. So if we differentiate 4x cubed, we'll get, what is it? 12x squared, eh? Now the x represents the inner function here. And what's my inner function? Sine 5x plus 2. So let's write that down again. So g dash, 4 times we are bringing the 3 down. And the power is now 2, eh? And we said the inner function remains. And then what next? We now have to differentiate the inner. What will the derivative of the inner be? Differentiate sine 5x plus 2. That alone has an outer, also has an inner. So differentiate sine 5x plus 2. What do you get? Because we'll multiply that to this expression that we've constructed. Yes, somebody? Times. Differentiating sine 5x plus 2. This on its own has an outer, which is sine. So if we differentiate sine, what do we get? Cos. What should we have here? We differentiate the outer, the inner remains. And then we now differentiate the inner. Simplify this. I want you to write down your simplified version. Go, write it down. Write down your simplified version of this, and let's check if simplest form you can write it down. Go, write it down. Got it? Yeah, give it to me. What do you have? 60? Where do we get the 60 from? 4 times 3 times 5. Agree? 60. Keep going. What else? Cos. What else? Sine squared. If you give me that, I will not give you the full marks, because there's a better way of writing this. What should it be? 60 cos times sine squared. Check your neighbor's answer. Is it the same as this? Why is it different? Tell your neighbor not to create his or her own concept, unless you're discovering something new. So this is a case where you use chain rule more than once. How much time do we have? Okay. Da-da-na-na. Which one shall we try out? F. Let's do F and G. F is 5x cubed sine 3x plus 1. Okay? What technique or techniques shall we use here? I see that there are two functions multiplied. Which two functions are these? One is 5x cubed, and the other is sine 3x plus 1. So if two functions are multiplied, what technique do we use? Product rule, eh? So I'll call this G, I'll call this H. So G dash, what's the derivative of G dash? 15x squared, yep. H dash, if we differentiate this, this will require chain rule, eh? So cos times differentiate the inner, which is 3. So if I am to find f dash, we know that we are using the product rule, so it will be G times H dash times G dash. So what's G? 5x cubed times H dash plus H